Okay, here we go. Integers. All right, integers. When we get done with this section, we'll be able to define what whole numbers are and integers are. We'll be able to find the opposite and absolute value of a number. We'll be able to compare numbers for relative sizes using our inequality operators. We'll be able to add and subtract, multiply and divide integers. We'll perform calculations using the order of operations. Okay. All right, this is the set of whole numbers. It's a set that consists of, actually, this is not the set of whole numbers. This is a set of counting numbers or natural numbers. If you want the set of whole numbers, you're going to have to throw in another element, namely 0. Okay. So this is the set of whole numbers. 0, 1, 2, 3, 4, 5. What do these little dots mean? It means that the set goes on forever, correct? So obviously there's an infinite number of whole numbers. And if you don't include 0, ladies and gentlemen, then you have the set of natural numbers or counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to infinity. Okay. Now, every natural number has an opposite or additive inverse. In other words, the opposite of a positive 2, we say, is a negative 2. And therefore, if we expand this set to go to the left forever, we have what is called the set of integers. Okay, so this is the set of consisting of integers. Now, when you go further to the left in this set of integers, you're going towards smaller numbers, always smaller numbers. And when you go to the right in this set, you're always going towards larger numbers. Okay, always towards larger numbers. All right, so this is called the set of integers. And of course, these dots mean that the set goes to the left forever and this set goes to the right forever. Okay, so integers basically involve working with not only the whole numbers, but also the negative. You could think of it as being like the negative counting numbers or the negative natural numbers also. Okay. All right, absolute value.
Is it possible for you to go back for just one more second, please?
All right. Now, I did make this available also at about 10:45 this morning, this PowerPoint presentation on Canvas. It's there for you to print out and do whatever you want with it. Okay.
Okay.
All right. Now, on the absolute value of a number basically just describes how far away from 0 the number is. So when you take the absolute value of a number, it's always going to return the positive value of that number because we're just interested in how many units away from 0 the number is. We're not really concerned with whether it's to the right of 0 or to the left of 0. Okay. The opposite of positive 1 is negative 1. The opposite of positive 2 is negative 2. The opposite of positive 3 is negative 3. Notice negative 1 is 1 unit to the left of 0. Negative 2 is 2 units to the left of 0. Negative 3 is 3 units to the left of 0. And basically, this is showing us that every number on this number line has an opposite. Now, that's not only true for integers. That's also true for rational numbers and irrational numbers, which include decimals and fractions. Because between any two integers, there's an infinite number of decimals and fractions. In other words, between 0 and 1, there's an infinite number of decimals and fractions. Between 1 and 2, there's an infinite number of decimals and fractions. Between negative 1 and negative 2, there's an infinite number of decimals and fractions. Okay, but we're just concentrating on the integers here today. But every integer has an opposite. Now, what would be the opposite of 0? Well, oddly enough, 0 happens to be its own opposite. There really is no such thing as negative 0, ladies and gentlemen. 0 is just 0, okay? Okay, so every integer has an opposite. All righty. So what would be the opposite of positive 20?
-20,
And what would be the opposite of negative 100?
+100.
Positive 100.
100.
Yep. All right. So basically this is just saying the absolute value of a number basically just returns the positive of that number. Okay. And the absolute value symbol that's used in mathematics are these vertical bars here. So if you enclose a number inside these vertical bars, you are said to be taking the absolute value of that number. So the absolute value of 11, that's how we interpret this, is 11. The absolute value of -6 is equal to +6. Okay. Okay. Find the opposite of each of these numbers. And so, Les Alman, I would like you to do A through C for classwork 1, A through C, and we'll do the other ones in a moment. Okay, so let's do A through C first. Okay, classwork 1, A through C. Go ahead. All right, so these are pretty simple here, ladies. What's the opposite of 100? It would be
-100.
-100. Okay. The opposite of a -50 would yield
50.
50, positive 50. Now you don't have to put the positive in front of the 50. You can if you want, but if you omit the positive sign in front of a number and you don't see any sign in front of a number, it's understood to be positive. Okay. So if you just want to see 50 or actually put the positive sign, go ahead. The opposite of 0 is
0.
now what's the absolute value of 26? How many units away from 0 is 26 on the number line?
6.
26 units to the right of 0, correct? So the absolute value of 26 is 26. How many units away from 0 is -99?
99.
99 units, albeit to the left of 0. It's still 99 units away. So we just say the absolute value of -99 is 99. Now, how do we read this notation here, F? Well, we would read this as the opposite. We reinterpret this sign as the opposite of a -10. What's the opposite of a -10?
+10.
Positive 10. So that really simplifies down to just positive 10. Now this is different because here in F we had parentheses, but here we have absolute value symbols. So this is to be interpreted as the opposite of the absolute value of -10. All right. Let me just actually spell that out. The opposite of the absolute value of -10. All right, so the way you deal with this is, first of all, you just take the absolute value of -10. So what's the absolute value of -10?
10.
10. But then we have to take the what of it, though?
Yeah, so it's -10.
The opposite of 10, which yields a what? A -10. Everybody see that there? Again, first I took the absolute value of -10, which is just 10, but then we have to take the opposite of that result. And the opposite of 10 is a what? -10. Everybody understand what just happened there? Do we understand the difference between absolute value versus just parentheses here?
Yes.
Oh, okay.
Night and day difference. In F again, it says we are to take the opposite of a -10, which is 10. But in G, it's saying something different. It's saying the opposite of the absolute value of -10. The absolute value of -10 is 10, but then we're going to take the opposite of 10, which yields a -10. All right, watch this one. Here's a little bit of a challenge problem. Let's see if we can negotiate this one. Okay, check this one out. What do you think this is going to simplify to? Well, we'll chip away at it. Let's go in here and do the absolute value first. What's the absolute value of -6?
Wait, positive 6?
The absolute value of -6 is 6. That's correct. +6. But then we have to take the what? The opposite of what? This result, correct? What's the opposite of 6?
-6?
-6. But then, ladies and gentlemen, check this out. We're not done yet. We still have to take the what? The opposite of that result. And what's the opposite of a -6?
A positive 6?
Yeah, the opposite of a -6 yields a +6. This whole thing simplifies down to just a +6 when it's all said and done. Because again, we did the absolute value of -6 is 6, but the opposite of 6 is -6. But then we have to take the opposite of a -6, which yields a +6. Would that be the same as if I did this? Same or different? If I did this? Is this also going to be a +6 when we get done?
No.
No, because here we have parentheses. We don't see absolute value anywhere, correct?
Yeah.
So we do this first in the middle, in the interior, we say we got the -6, and we are to take the what? The opposite of -6. So what's the opposite of -6?
6.
+6. But then we are to take the what? The opposite of that, correct?
So we make it -6.
Hey, I'm going to show you a shortcut here. Check this out here. Whenever you have just parentheses, all right, and you have a bunch of negative signs, all you got to do is count the number of negative signs that you see. So if you have something bizarre like this, to simplify this is pretty simple. All you got to do is count the number of negative signs. How many negative signs do you see here?
4?
There's 4 negative signs, and 4 is a what? An even number. Do you agree?
Yes.
But whenever you have an even number of negative signs in a situation like this, where you have nothing but parentheses, this always walks out as being a positive. So again, if you have an even number of negative signs where you have nothing but parentheses, and you have a number in the innermost nested parenthesis, then the overall result is a positive. Now, if you have an odd number of negative signs, like this is a positive, now how many negative signs do we have in this expression? There is now
3.
3, and 3 is an odd number of negative signs. Now, because we have an odd number of negative signs, okay, involved in this expression that has only parentheses, notice no absolute value anywhere. This would walk out being not a positive in the end, but a negative. Negative, okay? And that's also going to be true when we start multiplying integers together, this little trick, okay? You'll see how this comes back to revisit us. So just remember, if you have an odd number of negative signs involved in an expression only with parentheses and a number embedded in the innermost nested set of parentheses, the whole thing is a negative. If you have an even number of negative signs, the whole expression simplifies to a positive. A little shortcut there. All right. This is just giving us the answers that we had before. All right, number lines are useful in deciding which of two number integers are larger, okay, or is larger or is smaller. Because remember, the way it worked, the way I indicated earlier is, okay, if we have our number line here, and the arrows at the end indicate that this goes in both directions forever. If I have 0 here, 1, 2, 3, 4. All right, and then we go to the left, -1, -2, -3, etc. to the left forever. So this number line goes in both directions forever. Again, what did I say? If you go to the right, you're going towards larger or smaller numbers. How does that work?
The larger numbers to the right.
Right. You're always going towards larger numbers when you go to the right on the number line. Always. There is no exception. If you go to the left on the number line, you're always moving towards smaller numbers, and there is no exception to that rule. So knowing this fact here, you can easily compare, okay, integers for relative sizes. For instance, if I compare +2 with -2, okay, which one is greater and which one's smaller? Or excuse me, which one's larger, which one's smaller?
The +2.
Yep, -2 is further to the left than +2 on the number line. Therefore, -2 is less than +2, and we would use this inequality symbol and orient it this way to represent that fact. We say -2 is less than +2. Now, one way to remember how this inequality symbol points is you can think of it as it always points to the smaller of the two numbers being compared. Or here's an even novel, maybe a little more corny way of remembering it. Think of this as being an alligator's mouth, and the alligator hasn't eaten in about a year. It's starving to death. It's going to eat the bigger of the two things. Do you agree? All righty. So whatever works, ladies and gentlemen. Okay. So -2 we say is what? Less than +2. Could I flip this whole statement around and still have an equivalent statement if I said this? Is this still saying the same thing as what is being said below there?
No. Is it? I don't
Is
think
he
so.
saying the same thing?
No.
I think it's saying the same thing.
Yeah, it is.
Yeah.
Because look at the expression on the
Greater
top
than
is,
symbol.
yeah, the expression up here on the top is saying 2 is greater than -2.
Okay.
Well, that's saying the same thing. If 2 is greater than -2, that's synonymously, admitting that -2 is what? Less than 2. Correct? Yeah, these are saying the same thing. They're identical statements. All right. Okay, now let's have a little bit of fun here. How about -200 versus -500? Which is bigger? Which is smaller? Got to use a little imagination, ladies and gentlemen. If you go to the left on the number line, which number would you hit first? -200 or -500?
-200.
You would strike -200 first, which means you'd have to go further to the left to encounter -500, which means therefore -500 must be what? Less than -200, or -200 must be greater than the -500. Is that clear there? Okay. All right. Here's a pretty easy one. 300 compared to -1000. Which number is greater and which is smaller?
300 is greater.
300 is much greater than -1000. -1000 is way over here to the left.
Yeah.
300 is way over to the right, correct?
Yeah.
So that's obviously true. So yeah, I mean, the more negative your number becomes, if you will, the smaller it becomes. The more positive your number becomes, the larger it becomes. All right. So that's how we compare. And this holds true for fractions and decimals too, not just integers. All right. It's always true. The further you go to the left on the number line, the smaller your numbers get. The further you go to the right, the larger they get. All right, so here's some symbols. We're going to call this classwork number 2. I want you to basically put the appropriate inequality or the equal symbol, whatever the case may be, in between these two numbers so that we'll have a true statement. We'll call this classwork number 2. Go ahead and do that. All right, let's take a look here. 4 compared with -2, which one's greater?
The 4.
All right, so 4 is greater than -2. We must point our inequality symbol that away. What's greater, -20 or 0?
0.
0.
Okay, so 0 is greater than -20, or -20 is less than 0. Inequality must be oriented that way. -10 versus -7,
7 is greater.
7 is greater.
or -10 is less than -7, or -7 is greater than -10. All right, how about these two here? Bless you.
The 4 is greater.
This is the absolute value of, careful, the
Should be
absolute value of
They're
-4 is
equal.
what?
They're
It's-
equal.
Yeah, the absolute value.
Oh,
Yeah, these are equivalent to each other. All right,
Okay.
tricky one there. All right, let's move on there. Okay, and this is just showing the answers, of course. There's the number line. All right, so ladies and gentlemen, how are we going to add integers together? Well, in the early going, normally they show you addition via the number line, but we're going to discover very quickly we're going to have to get away from the number line because it's not robust in the sense that it can handle all problems. Okay, but for now we'll have the training wheels on. Using the number line as a tool to add 4 and 1, we'll start at 4. Okay, and then we must add +1 to 4, which means we have to move 1 unit to the right on the number line, and we land at what integer? We land at
5.
+5. So this is a graphical way or a pictorial way of representing 4 plus 1, which is 5. All right, let's try another one. How about we add a +1 to a -4? Now, we start at +1 on the number line, and we have to add a -4 to a +1, which means, ladies and gentlemen, we're not going to go in the positive direction 4 units. We're going to go into what? Negative direction
Negative.
from +1. So -1, -2, -3, -4. And where do we land? At what integer?
-3.
At -3. Son of a gun, look at this typo. That should be a -3. Please do make that correction. I don't understand why there's so many typos with these PowerPoints. I'm very disappointed with this. That should be -3. +1 plus a -4 is a -3. Please make that correction there. All right. Let's try another one. -3 plus a -4. We start at -3. And to -3, we're going to add a -4, which means we go 4 units from -3 in the negative direction. So -3 plus -4, -1, -2, -3, -4. Where do we land? We land at
-7.
-7. All right, so we're starting to see how we can, using number lines, add integers together. But ladies and gentlemen, this works. So do you agree the number line situation works okay for these examples?
Yeah.
Works okay for these. Do you think it's going to work for all examples?
No.
Let me give you an example here. I bet it don't work for this one. All right. Could you show this on a number line? -50 plus +1,200.
Ooh.
You know what I'm saying? I mean, how are we going to show that on the number line? That's so
Oh.
not happening. Do you agree?
Yeah.
All right. So we need more robust rules. All right. I mean, the number line way of showing things is okay in the early going for simple problems. It gives us an intuitive idea or a graphical idea as to what's going on. But we have to, ramp up to being able to handle all types of problems where we're adding all types of integers together, not just the nice ones that are close to 0. Okay. And for that reason, we have to become more robust in our thinking. And so what it's going to ultimately boil down to, ladies and gentlemen, is memorizing rules. And this is what rule number 1 is saying. They say it with a bunch of words. I'm going to say it much more efficiently than this. So rule number 1 is saying a positive added to a positive always gives you a positive. And we always add the numbers together. So a positive plus a positive is always a positive, and we add. A negative added to a negative plus a negative is always a negative, and we add. That's what rule one's saying here. So basically put, when you're adding integers together that have the same signs, okay, your answer takes on that common sign. So a positive plus a positive is always a positive, or a negative plus a negative is always a negative. In both cases, we add the numbers together. We add the numbers together. Here's an example for the first one here. If I have a positive 5 added to a positive 7, I'm going to get a positive what?
Well,
We add the numbers together, positive 12. We've known that rule for a long time now. Now, how about a negative 5 added to a negative 7? Now, look at when you have a negative number after like an operator of addition or subtraction, for the sake of clarity, you should enclose it inside inside parentheses, okay? Because this helps us to realize that we are adding a negative 5 to a negative 7. Now, you don't have to enclose the negative 7 inside parentheses, but listen, if you don't, you need to remember this. If you don't enclose the negative 7 inside parentheses, just make sure the negative sign is elevated so that it clearly looks like a what? A negative 7 being added to negative 5. If you write it this way, there's going to be nothing but chaos. Do you agree this don't make any sense whatsoever, does it? Looks like negative 5 plus subtract 7. Do you agree? Don't write it that way. If you're going to not include your negative integers inside parentheses, at least elevate the little negative sign so it clearly looks like it's a negative number, negative integer. All right. All right. Anyways, a negative plus a negative is going to be a what? Always a
negative.
negative, and we add. What's 5 plus 7?
12.
So
Negative
negative
12.
5 added to a negative 7 will be a negative 12. And it doesn't matter how big these numbers get or how small they get. So like if I have a negative 100, okay, added to negative 670, could you imagine illustrating this using your number line? That would be out of the question. But we now have a rule because we know a negative plus a negative is always a what? Negative.
Negative.
And we add the numbers together. So what's 100 added to 670?
770.
So our final result is going to be negative 770. So ladies and gentlemen, the key is we really just have to memorize these rules, whether you use flashcards to memorize them, okay, or whatever it takes. Let's just try to memorize these rules. So a positive plus a positive is always a what? Positive, and we add. A negative plus a negative is always a negative, and we what? Add.
Add.
That's rule number 1. You understand that? Rule number 1. Let me know when we all have this written down somewhere. Let me know when we got that written down.
I got it.
All right, so you got that there. Now, what's rule number 2 saying here? I'm going to clear this. Okay, can I clear this out here? That's rule 1. Here's rule 2. Rule 2 is saying this, and it's saying it with a bunch of gobbledygook stuff in here. And I don't really like the idea that you put the absolute value in as part of this rule. I have a much easier way to remember it. Rule 2 is saying this. When you add numbers together that have opposite signs, like a positive added to a negative or a negative added to a positive, here's what the rule, here's the rule we need to memorize. It comes in 2 steps. So when you add a positive and a negative or a negative added to a positive, you need to remember this rule. Step number 1, we always take the difference between the numbers. Take the difference. So we always take the difference between the numbers. We don't add the numbers together. We take the difference between. So yeah, we are subtracting the numbers. So we take the difference. And then what we're going to do, step number 2, is we're going to attach to our answer the sign that's in front of the larger of the 2 numbers. I like to shorten this up, ladies and gentlemen, and just say attach the larger sign to the answer. Okay. All right, so there you go. So when we add a positive and a negative or a negative and a positive, we, number one, take the difference between the numbers. And step number two, we attach to our answer the sign that's in front of the larger of the two numbers being added together. I just shorten up and say attach the larger sign. This should be saying attach the larger sign. Larger. Okay. All right, well, let's try it out on a couple of these here. If I got 7 plus negative 15. A positive 7 added to a negative 15. First, we take the difference. What's 15 minus 7? $15 minus 7 nets us a what? An 8. Now, which number is larger, 7 or 15?
15.
Listen close.
7.
I said, what number is larger?
Oh,
7 or
7.
15? No. 7 or 15?
15.
And
15.
15 is what? Negative.
Negative.
So our answer is what?
Negative 8.
Negative 8.
Yeah, I didn't say which number is larger between 7 and negative 15. I didn't say that. I said, what number is larger between 7 and 15? 15 is, but since the 15 is negative, our answer must be what? Negative. Okay. Now, you could reconcile it this way from a money standpoint. If you have $7, but you owe $15 to somebody, well, that means you got to pay not only the $7 you have in your pocket, but you're still going to be out $8. Do you agree? Make sense? You're still $8 in debt. Or if the temperature is 7 degrees above zero, ladies and gentlemen, and the temperature drops 15 degrees, well, not only are you going to lose your 7 degrees and get down to zero, you're going to lose 8 more degrees. You're going to be what? 8 degrees below zero before all is said and done. Does that make sense?
Yes.
Okay, so there's different ways to maybe kind of reconcile this from a worldly standpoint. But you know what? At the end of the day, when the sun sets, we really just need to memorize the rules. I'm telling you, that's the most efficient way that we're going to be able to work with integers in the future. So a positive plus a negative or a negative plus a positive, we take difference, attach larger sign. That's the rule. All right. So we're amassing some rules here now. Okay. Now it's a matter of, can we remember these rules? And that's what it always comes down to. Can we remember? You see them today, but will you remember them tomorrow and the day after and the day after, etc.? All right, help me out here, ladies and gentlemen. What's a negative 2 added to a negative 8? A negative plus a negative. What was it? A negative plus a negative is always a
Negative.
negative, and we add the numbers together. That was the rule. So what's a negative 2 added to a negative 8? It will net us a negative
10.
And
10. Now we're shifting gears. We're going from that rule to this rule. What's a negative plus a positive? Oh, we have a rule. First, we take the what? Difference between 8 and 6. What's the difference between 8 and 6?
Positive 2.
2. Now, what sign do we attach to the 2? Which number is larger, 6 or 8?
8.
8's larger, and it's what? Positive. And because of that, our answer must be what? Positive.
Positive.
Is it? There's the rule. Let's try another one. What's a positive 6 added to a negative 12? Well, a positive plus a negative, we take the difference. What's the difference of 12 and 6?
6.
6. Now,
But
do I attach a
negative.
positive or a negative? Which number is bigger,
Negative.
6 or 12? 12 is bigger
12.
than 6. But because it's negative, our answer is what? Negative.
Negative.
Do we understand how that rule is being applied?
Yes.
Okay. It's a matter of remembering the rules. That's what it's going to come down to. Can we memorize these rules? That's why you really need to rehearse them every single day. Positive plus a positive is always a positive, and we add. A negative plus a negative is always a negative, and we add. A positive plus a negative or a negative plus a positive. 2 steps. Number 1, we take difference between numbers. Step 2, we attach larger sign. These are the rules we've learned so far. Okay. So it's going to come down to, can we remember these rules? And the sooner we remember them, memorize them, the better our life is going to be, well, in this course. Okay. Now, unfortunately, I wish that was all the rules we had to deal with, but there isn't. There's more. Ladies and gentlemen, how do we subtract? Now, some of you, I know what you're thinking. Wait a minute. Back over here, when I was adding a negative 6 to an 8 or a 6 to a negative 12, weren't we taking the difference between the numbers? Yes, we were, but we were really doing what kind of an operation, though?
Addition.
We were adding. I know it's strange, but we were adding numbers together. But yes, according to the rule of adding opposite sign numbers together, we do take the difference before we attach the larger sign. All right, but ladies and gentlemen, here's how we need to formally think of subtraction. Let's go back to grade school for a moment when life was good. What's 7 subtract 2? A kindergartner could tell you this. Do you agree? They could do this on their hands probably. And they would get what?
5.
5. Okay, we've known that for a long time. Now watch this. What's 7 plus a negative 2? Oh, we just learned this rule. What's a positive plus a negative? We take the what? Difference.
larger.
Well, we take the difference first, and then we attach the larger sign. Now, what's the numbers larger, 7 or 2?
7.
And it's what?
Positive.
Positive. The answer must be positive. Now, this is weird. We seemingly have two different problems here. 7 subtract 2 gives us 5, but 7 plus a negative 2 gives us 5 also. Is that just a coincidence, or are we on to something very important here? It's not just a coincidence, ladies and gentlemen. We're on to something really big. This is how we need to think of subtraction. When you take some number A and subtract off some number B, you can always change subtraction to
Addition.
addition. But in doing so, you must add the opposite of what's being subtracted. What's the opposite of B?
Negative.
Negative B. So A subtract B is equivalent to as if I say A plus a negative B. Let's look at that again. If I take some number A and subtract off some number B, this is equivalent to as if I take number A and add to it the opposite of B. What's the opposite of B?
Negative.
Negative B. Now watch this. What if I have some number A and I subtract off some number called negative B? Again, we can change subtraction to what? Addition. We can change subtraction to addition. But we must add the opposite of what's being subtracted. What's the opposite of negative B?
Positive B.
Positive B. See this? Subtraction is equivalent to adding the opposite. And if we can memorize this rule, we'll stay out of trouble with our subtractions. Let's have a little bit of fun and try one out. How about 7 subtract 30? Now, I know a kindergartner would not be able to do this number. They would say you can't do it. Well, we know how to do this now, ladies and gentlemen, because we're more advanced. We can change subtraction to what? Addition.
Addition.
But in changing subtraction to addition, I add the opposite of 30. What's the opposite of 30?
Negative.
Negative
30.
30. So 7 subtract 30 is equivalent to this, 7 plus a negative 30. But we have a rule for this now. A positive plus a negative, the rule says we take the what? Difference? What's the difference of 30 and 7? The difference.
23.
23. Now, would it be positive or negative as we attach the larger sign?
Negative.
Negative, because 30 is bigger than 7 and 30 is negative, so our answer must be what? Negative. So as it turns out, 7 subtract 30 is a negative 23. All right. Let's do 7 subtract a negative 30 now. Well, this looks even more complicated, but we know how to change subtraction to an equivalent what?
Addition.
We change subtraction to addition. But the price we pay in doing that is we must add the opposite of what's being subtracted. What's the opposite of negative 30?
Positive 30.
Positive 30. So, ladies and gentlemen, would you believe it? A 7 subtract a negative 30 is really equivalent to 7 plus 30, which gives us 37. It is. That's your answer, 37. So subtraction, again, is equivalent to adding the opposite. We really need to just memorize this rule here, ladies and gentlemen. So subtraction is equivalent to adding the opposite. All righty. Subtraction is equivalent to adding the opposite. Okay, hopefully you've written that down or taken a picture of this or whatever. All right, let me know when we got this counted for. Are we all good on this?
Yes, I am.
Okay. Let's move on. Now, the key to success is obviously going to be a lot of what? A lot of practice, okay? And I'm going to give you a lot of practice. In fact, I'm probably going to supplement your practice not only on Alex, but I'm probably going to give you some supplemental worksheets I'll post on Canvas. It's gonna be supplemental practice, ladies and gentlemen. You don't have to turn the problems in. I'm just gonna give you the extra practice along with the answers. So if anybody out there wants and needs extra practice, please do, by all means, invest some time in the extra practice I'll post on Canvas, okay? All right. Okay, are you ready for classwork number 3? We'll call this classwork number 3. I want you to simplify each of these or evaluate each of these. -2 minus a -8, 3 subtract a -7, and -2 subtract 6. Go ahead, see if you can employ the rules we've learned so far with subtraction. These are all subtraction problems. I want you to see if you can rewrite these as an equivalent addition problem and actually add correctly. Go ahead and do those. All right, so -2 subtract a -8 is going to be equivalent to -2 change subtraction to what?
Addition.
Addition, but we must add the opposite of -8, which is to say we add, what's the opposite of -8? +8. Now we're going to shift gears to the other rule we learned today. A negative plus a positive, we take what? Difference?
Yes.
Difference of 8 and 2 is 6. And now we're going to attach what to our answer? A positive or a negative sign? Which is bigger, 8 or 2?
8.
8's bigger and it's what? Positive. You got your answer. -2 subtract a -8 works out to give us a +6. 3 subtract a -7, is it going to be equivalent to 3 change subtraction to addition? 3 plus, but then we must add the opposite of -7. What's the opposite of -7? Positive. And 3 plus 7, a positive plus a positive is positive, and we add +10. Finally, -2 subtract 6. We change subtraction to what?
Addition.
Addition, but we must add the opposite of +6. What's the opposite of a +6?
-6.
-6. This is really equivalent to -2 plus a -6. And a negative plus a negative is always a
Negative.
negative, and we add. So it'll be a -8. I know it sounds kind of cruel, ladies and gentlemen, and stringent, but the rules really are what we need to memorize. I'm serious. The sooner we can memorize these rules and get comfortable with them, obviously we're going to fly through these problems with great confidence. Okay. But that's going to only come through practice and a lot of practice. So I'm going to give you a lot of practice. All right. Any questions about any of those? All right. Moving onwards now. Here's actually an example of a worldly problem. If you have a PayPal account, you can add money to your account, giving you a positive balance, or you can spend more than you currently have in your account, which would result in a negative balance. A 5-day history for an active internet shopper is given below. On Monday, the balance in our account was plus $12. On Tuesday, the balance was negative $5. On Wednesday, the balance was negative $16. Thursday, the balance was negative $25. And on Friday, the balance was $20. Okay. Do we understand? These are the balances on given days, correct, for this account. Now, what do they want us to do with all this? Well, in A, it says find the sum of the balances for Monday and Tuesday. The sum of the balances for Monday and Tuesday. So what am I going to add together for the balances of Monday and Tuesday? A positive 12 added to a what?
-5.
Negative 5. And a positive plus a negative, we have a rule that says we take the difference, which is 7, and we attach the larger sign, which 12 being larger than 5 and it being positive would be a what? A positive.
Positive.
So at the end of the day, Tuesday, our balance would be a what? A positive 7. Does that make sense? Positive $7. These are dollars, okay? That makes sense?
Yes.
All right. Part B, find the difference. Oh, careful. Find the difference means we're going to have to subtract. Find the difference of the balances for Thursday and Friday. The differences between the balance of Thursday and Friday. So what does that mean we're going to do here? Well, we're going to subtract. Difference means subtract. So we could take Thursday's balance, which is negative $25. I'm leaving the dollar sign off. And we're going to subtract off the balance on Friday, which is $20. Well, negative 25 subtract 20 can be rewritten as an equivalent addition problem as negative 25 plus change subtraction to addition. But what's the opposite of 20?
-20.
And what's a negative plus a negative?
Negative.
Negative, and we add, agree? So this would be negative what? $45? Now, what's that saying? Is that saying we have we're minus $45 in our account? Is that what that's saying? No. What that's saying, ladies and gentlemen, is that's the difference between our balance at the end of Thursday versus our balance at the end of what? Friday. So we went from being what? $25, minus $25 in our account to positive $20. That means it's a difference of what? $45, correct? Isn't that a difference of $45?
Mm-hmm.
In other words, we must have added how many dollars to bring our account from negative 25 up to 20?
A positive 45?
Must have added $45 into our account. Yeah. They just wanted us to, investigate the difference between the balances on the 2 given days. The difference was $45. Okay. All right. What does this result say about subtracting a negative? Well, when we subtract you know what? They wanted me to do this differently. They wanted me to take the balance at the end of Friday and subtract off the balance at the end of Thursday. Do you agree? I should have worked the problem out this way. I apologize. So therefore, subtracting negative 25 is equivalent to adding a what? What's the opposite of negative 25?
Positive.
And these add together to give us what? $45?
5.
So I should have done the problem this way because this illustrates that we added what? $45 to our account from Thursday to Friday, correct? That true?
Mm-hmm.
Okay. So that makes sense. Okay. All right. Now, what are the rules for multiplying and positive and negative numbers, or multiplying negative or integers together? Well, rule number 1 is saying this. It's saying that when you multiply a positive and a positive together, so a positive times a positive, notice I'm using the dot operator for multiplication. A positive times a positive is always a positive. And a negative times a negative is always going to be a positive. Caution. We got to be careful not to get this rule mixed up with what rule? A negative plus a negative. A negative plus a negative is always a what? Negative. But a negative times a negative is always a positive. Try not to cross these wires. Okay? Got to keep those separate in your mind, ladies and gentlemen. They're totally different here. A negative times a negative is always a positive, but a negative plus a negative is always a negative. Always the case. That's what rule 1's saying. So if I have like a -2 being multiplied by a -5, by the way, there's many ways to show -2 times -5. I could show it that way, or I could represent it this way. This is implying that it's -2 times -5, or I could write it this way. This is also implying -2 times -5. In either case, a negative times a negative is always a what?
Negative.
Positive.
Negative times a negative is always a
Positive.
positive. A negative plus a negative is always a negative. So this is going to be a -2 times a -5 is a positive what? Positive 10. Okay. And obviously a positive 7 multiplied by a positive 10, in which case there's many different ways to show 7 times 10. All these are equivalent ways of showing 7 times 10, okay? They're all equal ways of showing 7 times 10. And in each case, we get what for a product?
70.
70, okay? We good on that rule? So when you multiply numbers together that have the same signs, you always get a positive. That's an easy way to remember it. Positive times a positive, always a positive. Negative times a negative, always a positive. All right, we got that rule? Okay, what happens when you mix the signs and multiply? That's what rule 2 is saying now. If I take a positive times a negative, or if I take a negative and multiply it by a positive, I always get a what? Negative. You always get a negative. Yep. So when you mix the signs and multiply, you always get a negative. So a -3 multiplied by a positive 10 is going to net me what?
-30.
-30. If I take a positive 17 and multiply that by a -5, that's going to give me negative 85, I believe. 85. True. All right, so a positive times a negative is always a negative, or a negative times a positive is always a negative. Now we have all the rules for multiplication. Any questions about any of these, or we have these all accounted for?
Yeah.
All right. Now here's the good news. Here's the beautiful news. The rules for multiplication are identical for the rules of division with signed numbers. All right, yeah, they're the same. Yeah, so there's good news around the bend here. All right, we'll call this classwork number 4. Go ahead and multiply these together and see if we can get these. Multiply these together. Oh, challenge problem here at the bottom. You don't have to do D yet. Just do ABC, okay? Classwork 4, ABC.
This
All right, number A here. A negative times a negative is always a what?
Positive.
Positive. So it better be positive 24. All right, number B rather. Positive times a negative is always a
negative.
negative. Negative 27. C, negative times a positive is always a
Negative.
Negative.
5 times 16 is 80, so negative 80. All right, I'm going to help you out with this last problem here. There's 2 different ways of doing this problem. One is the long way, but it will give you the same correct answer as the shorter way. I'm going to do the long way first. I'm going to work from left to right and work with 2 of these numbers at a time. What's a -6 times a -3? A negative times a negative.
Positive.
It's going to be a positive, positive 18, correct? All right.
Mhm.
Now I'm going to bring down everything I haven't gotten to on my next line. This is foreshadowing something to come when we get into the order of operations. We want to show all our steps. All right, now continue to work from left to right. What's a positive 18 times a positive 8? Positive times a positive is a
Positive.
Positive. What's 8 times 18?
144.
44.
44. Bring down the multiplication, bring down to -5. Now we're going to close this problem out by taking a positive 144 and multiplying it by a negative. What's a positive times a negative?
Negative.
Negative.
Positive
negative.
times a negative is always a negative. And 5 times 144, this is even worse now.
720.
720, thank you. Final result must be set negative 720. Ladies and gentlemen, there's a shortcut. The shortcut basically has you counting the number of negative factors you have here, or the number of negative signs. Remember, we use that shortcut when we're working with simplifying an expression with only parentheses.
Yes.
How many negative signs do you count in this entire expression?
3.
3 of them. And is that odd or not, or odd or even? It's an odd number of negative signs in this product or this multiplication problem. There's an odd number of negative factors. Therefore, since it's an odd number of negative factors, the product will be negative. If there was an even number of negative factors, the product would be positive. Okay. So we know it's got to be negative, and all you gotta do is multiply now. 6 times 3 is 18, times 8 is 144, times 5 is 720. So it's got to be negative what? 720. A little bit of a shortcut there. Okay. If you want to work this way, fantastic. No problem whatsoever. Okay. I'm just showing you that there's a little shorter way to do this problem if you're in, pinch for time. An odd number of negative signs in a nothing but a multiplication problem means your product will be negative. If you have an even number of negative signs in your multiplication problem, it would be a positive. So this would be a positive if I had 4 negative signs as opposed to 3. Okay. All right. Division. The rules are the same for division, ladies and gentlemen. So what's a negative divided by a negative? It will always be a positive. What's a positive divided by a positive?
Negative.
No, a positive divided by a positive is always a positive because a positive times a positive was always a positive. When you mix the signs, a negative divided by a positive or a positive divided by a negative. In either case, we're going to have always a what?
Negative.
Yeah, it will always be a negative in this scenario here. Okay. So the rules again are identical between multiplication and division for signed numbers. The rules don't change. That's the good news there. So if I take a positive 12 and divide it by a positive 2, I get a positive what?
6.
Positive 6. Okay. All right, ladies and gentlemen, you try these problems here. We'll call this classwork number 5. Let's do our divisions here. Remember, the rules for division are the same for multiplication when it comes to the positive and negatives. No difference. Go ahead and try those. All right, a positive 32 divided by a positive 8. A positive divided by a positive is a positive 4. A negative 27 divided by a negative 3. A negative divided by a negative is always a positive 9. A negative 42 divided by a positive 7. A negative divided by a positive is always a
Negative.
negative 6. Positive 20 divided by a negative 5. Positive divided by a negative is always a
negative,
negative 4. Trick question. 8 divided by 0 is not 0.
Eight.
Not 0.
Possible.
It's undefined. Anything divided by 0 is called what? Undefined.
Oh,
You can never divide anything by 0. Can you divide something by 0 and have something that's defined? The answer is yes. So if I had this spun around, if I had 0 divided by 8, this is defined to be what? The integer 0. Okay? But 8 divided by 0 is undefined. You can never divide anything by 0. So anything divided by 0 is what? Undefined. All right? Can't do it. But 0 divided by any non-zero number is always defined to be what? 0. Provided you're not dividing 0 by what? 0. Okay. So there's a difference, huge difference here. Make sure you document and note the difference here. Okay. All right, write that down.
Yes, hold on.
Note the difference. And if you're going to computer programming, you got to make sure your computer program never involves a division by 0. Because if it does, that can cause your program to crash and can maybe even cause your computer to basically hang up. So programmers have to be very careful never to allow for a division by 0 in their code. All right. We got this, ladies and gentlemen?
good to go.
Okay. Order of operations is the only other thing that stands between us and the end here. Okay. Order of operations. How many have ever heard of the order of operations before? I can't see a show of hands, but I'm assuming that you may have seen it somewhere in the past, correct?
Yeah.
yeah,
If not, we're going to show you from the ground up anyways. Order of operations. And the order of operations is, pretty darn important because, like, if I gave you a problem like this, like 10 subtract 2 times, let's say, like, 15. What would we do first, subtract or multiply? Well, suppose in one country they believe that they should subtract before they multiply. Okay, well, let's see. What would be 10 minus 2? Well, that's the same thing as 10 plus a negative 2, which is what? 8, correct?
Mm-hmm.
How it's 8 times 15? Well, that'll give you, let's see, 120, I believe, correct?
Yeah.
Suppose in a different country, however, they argue, no, we're not going to subtract first. We're going to multiply before we subtract. Would they get the same answer? Well, let's find out. We would have 10 subtract. Now, what's 2 times 15? 30? Suppose they multiplied before they subtracted. Oh, what's 10 minus 30? Oh, that's 10 plus a negative 30, is it not? Oh, but 10 plus a negative 30 is a negative what? 20, isn't it?
Yeah.
You see the problem we would have here, ladies and gentlemen? If we could not agree on planet Earth as to how to plow through a simple numeric expression as this? Could engineers in this country ever build something together with engineers in the other country if they could not even agree on what the answer to this problem should be? Wouldn't that be a nightmare? It would so not happen, okay? So mathematicians had to get together worldwide and adopt what's called the Order of Operation Convention on planet Earth. And on planet Earth, ladies and gentlemen, we all agree, even if we go to war with other countries, we still agree upon one thing, the order of operations. So mathematics, in a sense, is a universal language. No, on planet Earth, ladies and gentlemen, we don't subtract before we multiply. This is incorrect. On planet Earth, the only answer to this numeric expression is negative 20. We need to what? Multiply before we subtract. Order of operations. All right. Are the order of operations important when we get, let's say we get up in the morning as to how we get dressed and go through our routine? Do we put the deodorant on before we take a shower or after we take a shower? Well, if you want to waste money, you put it on before you take the shower. Do you agree? And accomplish absolutely nothing. All right. No, there's an order of operations in our daily routine, ladies. We all have order in our lives. The universe has order to it, very specific order. Okay, let's take a look. What is the highest precedence whenever, trying to wade through a numeric or variable expression in algebra? We always have to pay attention to things that are inside grouping symbols first. The number one precedence belongs to things inside parentheses or brackets or braces or inside absolute value symbols. I'm going to add something to this. Suppose, ladies and gentlemen, we have something even more involved in this. Suppose that we have a set of braces, but embedded in my set of braces is a set of brackets. But embedded deeper in the side of set of the brackets is a set of parentheses. What would we do first, second, and third? The order of operations say when you have nested grouping symbols such as this, you would go into the innermost nested grouping symbols first. So we would do what's inside the parentheses first. Then we would simplify what's inside the brackets next. And last, we would deal with what's inside the set of braces. That's the order in which we proceed with complicated expressions when we have a nested grouping symbol situation. Everybody see that there? Always work with the innermost nested set of grouping symbols outward in that situation. All right. After dealing with things inside grouping symbols, oh, by the way, this is equivalent to as if you just used parentheses for all your grouping symbols. So, ladies and gentlemen, there's no difference between brackets and braces and parentheses. If we used all parentheses, we would still do what's in the innermost nested set. Do you agree? And then we would venture out to the nested set of parentheses, and then finally the outermost set of parentheses. That's still the order that we would pursue, same as we had parentheses, brackets, and braces. So why do they have brackets and braces? Well, here's why. When they have brackets and braces and parentheses, and you have a nested grouping situation, it's nice to use brackets and braces in addition to parentheses because it throws up a flag and it reminds us that we have a nested grouping situation. That's why they use the different grouping symbols to emphasize that fact. All right, after we deal with things inside grouping symbols, we deal with exponents. What are exponents? Exponents are things like this. How do we read this expression? Anybody want to help us?
2 to the third power.
To the third power, or 2 cubed. We say 2 is being cubed, or 2 raised to the third power. What does that mean we are to do? Does it mean we are to multiply 2 by 3 to get 6? This
2 times
exponent
2
of
times
3 is
2.
telling us how many times we multiply the base 2 by itself, correct? This is suggesting 2 times 2 times 2, which gives us 8. So don't think for a moment 2 cubed or 2 to the third power is 6. No, it's 2 times itself 3 times, which is 2 times 2 times 2, which is 8. Those are called exponents, all right? Then, ladies and gentlemen, we move down to multiplications and divisions, which receive the next level of precedence. And in particular, we work strictly from left to what? Right. What is that saying? What's this left to right business? Well, I'll show you. If I had 50 divided by 2 times 5, what would I do first? Division or multiplication in this case? Well, since these operators are on the same level of precedence, we work strictly from what? Left,
Right.
right. That's part of the order of operation convention. So we do division in this case first because it appears first before multiplication from left to right. So what's 50 divided by 2? 25. Now what's 25 times 5?
50.
125. Yeah. 5 times 25 is 125. That'd be your final answer here. So in that case, we would what? Divide before we what? Multiply, correct? Everybody
Yes.
understand that there? All right, but what if I had it written this way? What if I had 50 times 2, okay, divided by 5? What do we do first in this case?
Multiplication.
Yeah, we work from left to right. We multiply first in this scenario. So we'd have 100 divided by 5, which reduces down to just 20, correct? Or gives us just 20. So again, when your operators are on the same level of precedence, you work strictly from what? Left to right, left to right. That goes for additions and subtractions too. When you have an expression involving only additions and subtractions, you work from left to what? Left to right. So this is the order of operation convention. A way of remembering this is to attach a nifty acronym to it. P, E, M, D, left to right. A, if I can ever write an A. Writing with the mouse is a trip. A, S, from left to right. Please excuse my dear Aunt Sally is a way of remembering the order of operations. Please excuse my dear Aunt Sally. Please, P, parentheses. Excuse, E, exponents. My, M, my. Multiplication. Wait. My, M, multiplication. Dear, D for divisions, left to right. A, aunt, additions. Sally, S, subtractions, left to right. Please excuse my dear Aunt Sally. Order of operations. All right, what do I do first here? Order of operations. Parentheses. You got to do the parentheses first. What's 15 divided by 5?
3.
3. Notice they bring everything else down to the next line. They put an equal sign. Now what do we do next? Multiply or subtract? Order of operations.
Multiply.
Multiply. 9 times 3 is 27. Bring down to -3. Finally, 27 minus 3 is 24. Everybody understand how we showed our work here?
Yes.
Apply the order of operations. Please do show your work step by step by step. That keeps you out of trouble, stays off silly errors, okay? This is
1
called-
second before you go.
Yeah. This is called the order of operations. And the beautiful thing about this convention is it's worldwide, it's global. So no matter if if you have somebody from China computing this, or somebody from Africa or Australia or France or Russia or Germany or Jakarta, Indonesia doing this problem, doesn't matter, ladies and gentlemen. We're all going to get the same answer of 24. And if we don't, then we're not abiding by the order of operation convention, which is globally accepted worldwide. You type this expression into any calculator or any computer system on planet Earth, it better give you 24. If it doesn't, we scrap the machine. It's ill, it needs to be abandoned. It's no good, okay? That makes sense? Yes, all computing machines have been programmed to abide by the order of operation convention in mathematics. At the factory, they all been programmed to abide by the order of operations. All right, we ready to move on?
Yes.
Stop and think why that's important. If our engineers in this country are to collaborate with engineers overseas in building whatever it is, you agree we got to be on the same page with the order of operations?
Mm-hmm.
I mean, can you imagine it'd be nothing but arguments? No, it should be 24. No, it should be 50. I said 24. I said 50. You want to go to war on that? You know what I'm saying? Could you imagine the chaos? So the order of operations are pretty important, ladies and gentlemen, if we're ever to accomplish anything numerically on this planet. All right, here's a much more involved problem. What would we do first? We have parentheses. I see exponents. I see multiplications, divisions, additions, subtractions. What do we do first?
Parentheses.
Parentheses. The action begins in here. 8 subtract 10 is the same thing as 8 plus a -10, which gives us a what? -2. We good on that?
Mhm.
What do we do next? Multiply, add, exponents, or division? Please excuse E for exponents. We need to do 2 to the 3rd power next, which is 2 times 2 times 2, which gives us 8. What do we do next? Oh, are these parentheses necessary around a -2?
Yes.
Well, I mean, not really, but if you don't use them, you better elevate that little negative sign so it looks like -2 and not subtract 2. I would just leave the parentheses around a -2 for clarity. All right, what do we do next? Multiply, add, or divide? Multiply. Add, or divide. Now, multiplication and division are above addition, but we work strictly from what? Left to right then, and we encounter multiplication before the what? The division. Technically, we should probably what? Multiply before we divide, but you know what? the author says, well, it doesn't really hurt here too much to also divide at the same time. And it really doesn't at this particular point in our problem. What's a positive 5 times a negative 2? A positive times a negative is always a
Negative.
negative. So it'll be negative 10. What's a positive 8 divided by a positive 4?
So,
Positive 2. Finally, we add. What's a negative plus a positive? We take the difference and attach the larger sign. What's negative 10 plus 2?
-8.
Negative 8. Ladies and gentlemen, this all boils down to negative 8. If you were to type this all in on a calculator, all on one line, we would get the same answer. Okay. And you could even convince yourself, if you have a scientific calculator, type that all in on one line and you'll get the same answer. I don't have the TI-30 with me, but I do got the TI-84, and I can show you quickly that we would get that answer. Okay, watch how I type this in literally as I see it from left to right on my calculator. 5 times, open parenthesis, 8, subtract. Oh, on calculators, there's a difference between the subtraction button and the what? Negative button. See on the TI-84, this is subtraction. This is what? Negative button. Careful. There is a difference. Okay, so 8 minus or 8 subtract 10, closed parenthesis, plus 2 raised to the third power. My power button on a TI-84 is just below the clear button. Looks like a little hat symbol. Raised to the third power. Right arrow key to bring the cursor back down to level. Divided by 4. Equals, watch this. It better give me negative 8, because if it doesn't, I'm going to tether this TI-84 behind my vehicle and drag it down the road, because it's no good. Okay. It works. Everybody see that? Your calculator has been programmed to obey the order of operations, ladies and gentlemen. And if it doesn't, you got to get rid of the machine fast. You know, plant flowers in it or something. Get rid of it. Everybody understand that? All right. Let's move on here. I got to erase all this. Hold on. Ooh, even nastier problem. But ladies and gentlemen, the key is take a deep breath, relax, and begin to chip away at it, one little step at a time. You'll get it all done. Don't try to do it all at once. You try to gobble this up all at once. I'll tell you what, it's like trying to gobble down a full steak in your mouth all in 5 seconds. Good luck. Keep me tuned on that one. Okay. Ladies and gentlemen, there's too much going on here. So just relax. Remember the order of operations. What do we do first? Well, grouping symbols. But in this case, I have nested grouping symbols. Nested deeper inside my braces is a set of brackets. But nested deeper inside a set of brackets is parentheses. Where does the action begin?
Parentheses.
The innermost nested set of grouping symbols right here. We got to do 15 minus 2. That's all we have to do first. And so what is 15 minus 2? Well, that gives me what? 13. Notice they bring everything else down from the previous line. They don't lose anything from line to line. That's critical. Including your grouping symbols. Don't forget to bring those down to the next line. Now we're still inside the brackets. We do 10 plus 13. What's 10 plus 13? 23.
23.
And we can drop the brackets around the 23 because the brackets are no longer serving any purpose. Isn't that true? Everybody see that there? They dropped the brackets. Still inside the braces. What's 3 times 23? That's next. 69. And they dropped the braces around the 69, which can be dropped. If you want to leave them around the 69, you can do that, but they're not really needed anymore. What do we do next? Divide or subtract? Division.
Divide.
Yep, has higher precedence subtraction. 84 divided by 4 is 21. Finally, 21 subtract 69 is the same thing as 21 plus what? Negative 69, as we've learned. Positive plus a negative, we take the difference between these numbers and attach the larger sign, and we get negative 48. Final answer. Everybody see that there? Final answer. So the key is just have patience and relax, ladies and gentlemen. Just remember your order of operations and chip away at it. You will be able to conquer the biggest, nastiest expression if you do that. All right. You want to check your answer on a scientific calculator? By all means, go ahead and do that. So how would I type this in? 84 divided by 4, subtract. Now, I don't have an open brace. I do, but I'm not going to use it. I'm just going to use an open parenthesis in place of the open brace. Remember I said parentheses, brackets, and braces are really equivalent to parentheses. Same thing. 3 times, instead of an open bracket, I'm just going to use another open parenthesis. Okay, 10 plus open parenthesis, 15 minus 2. Closed parenthesis, closed bracket, but closed parenthesis. I'm going to use closed brace, but I'm going to use a closed parenthesis. Ladies and gentlemen, I'm ready to compute this. Hit enter and boom, negative 48. Everybody see that?
Yes.
My calculator obeyed the order of operations, and it has to. I mean, otherwise it's a worthless machine because all the computing devices have been endowed with the order of operation convention that we've established on this planet.
Can
Now,
you try
what's that?
can you try that same problem with just missing a parenthesis?
Not missing an open parenthesis. You might get away with missing the last parenthesis at the end there. You see that?
Okay.
Your calculator might be forgiving in that regard. But yeah, if you miss any open parentheses, that's going to be a big problem. Okay. Because you're going to lose your precedence. All right. Now what they do on planet Mars is anybody's guess, but on planet Earth, ladies and gentlemen, we always abide by PEMDAS. Please excuse my dear Aunt Sally. That's how we operate on planet Earth. Okay. All right. Suppose you have a checking account set up just to pay your share of the rent each month. At the start of the school year, there is $1,100 in the account. You write a check for $240 on the first of every month from August to May, and you deposit a student loan check for $600 at the beginning of each semester, fall and spring. Write an order of operations problem based on this situation, then find the ending balance in your account. Well, golly, what do you think we would start with first? Maybe the fact that we have $1,100 in our account, maybe, correct?
I think so.
Maybe start with that first. That's a starting place of our balance, our starting balance. You write a check for $240 on the first of every month from August to May. How many months is that, August to May? August, September, October, November, December, January, February, March, April, what, May? 10 months? So I'm going to write a check for 10 months. I'm going to write 10 checks, one at the beginning of each month from August through May for $240. It seems to me like I would be subtracting off then something. Do you agree?
Yes.
Subtracting off 10 times what?
240.
$240. That takes care of the 10 months, August through May, August to May. That takes care of that. But then it says, and then we deposit a student loan check for $600 at the beginning of each semester, which would be fall and what?
Spring.
You know, I'm thinking that I don't see the winter semester in here, do you?
Nope.
You know, it looks like there's only 2 semesters, fall to spring. That's it. All right. Well, we're depositing $600 how many times then?
2.
2 times. So we're adding back to our account $600 2 times. So it seems like plus what? 2 times 600?
Yeah.
That's how I would interpret writing this problem out. Now, the order of operations would have us doing what first here?
The parentheses. I mean,
Well, we don't really have any parentheses.
10 times 240.
We would probably multiply these together what first? Do you agree?
Yeah.
So that'd be 1,100 subtract 10 times 240 is what? $2,400?
Mm-hmm.
Plus, hey, you know what? It would not be a crime if we also multiply these together at this point in time. That would give you what? 1,200? That's okay. You can do that too. All right, now what do we do next? Order of operations. We work from what? Left
Right.
to right, because we have subtraction, addition, left, which are on the same level of precedence. So it's 1,100 subtract 2,400. You agree that's gonna be 1100 plus a what? Negative 2400?
Mm-hmm.
Heck, when you write it this way, you know what? Technically, the left to right is out the window now. Do you agree? Because I have nothing but additions all the way across, do I not?
Yeah.
But we could still work from left to right if you want. Or another way, ladies and gentlemen, when you're adding a bunch of integers together, you can add same sign integers together first and then deal with adding the opposite sign integers together last. So I can take a positive 1100 and add to it a positive 1200 first. What would that give me? Positive 2300, correct? And then finally, I can add to that a negative 2400. And a positive plus a negative, we take the what? We take the difference. Do you agree?
Yeah.
Take the difference and attach the larger sign. So what's 2400 minus 2300? That'd be 100, positive or negative?
Negative.
Negative. Uh-oh. It looks like our account is $100 in the red. Do you agree? As they say, not in the black, but in the red. In other words, we're in trouble. We bounced a check. $100 minus 100 is our account balance at the end of the day, and we have to address that. So there you go, ladies and gentlemen. See how we set it up and then evaluate it according to the law of operations there. All right, that's quite a problem, isn't it? All right,
Yeah.
so go ahead. Let me know when you all got this written down here.
So far as knowing the symbols you're supposed to use, it's all about the wording in the box.
Yeah, it's the wording. If you write a check, that means you're taking money out of your account. So that would be a what? A minus, correct?
Okay.
If you deposit money in your account, that means that's a what? That's going to be a positive. You're adding to your account, correct? All right. So yeah, when you write a check, that means a minus, and when you deposit, it means a plus. Or, ladies and gentlemen, how about debits versus credits? Do we understand the difference between this if you have a checking account? What's a debit? Is a debit adding money to your account or taking money out?
Taking money out.
Yeah, a debit is a minus. You're taking money out. Credit, when you credit your account, you are adding to your account. A credit is a plus. So debit is a minus from your account. A credit is adding money to your account, right? So obviously, hopefully we all credit our account more than we what? Debit it, correct? Whenever you make a purchase from your checking account, the money is debited from your account. If you make a deposit into your account, the money is added to your account. That's called a credit. All right.
Okay.
All right, get that all down. Let me know when you're ready to move on.
Yeah.
All right, let me know when we got the green light. Hey, is there any sport out there in the real world that makes use of negative scores? Negative scores. You know, it's not football or it's not baseball, correct? All those scores are positive numbers, correct? But is there any sport out there, think about it, that
Golf.
uses, what's that?
Golf.
The game of golf. You are correct. In fact, the more negative the score is in golf, the better your score is. In fact, at the end of a tournament, to be, let's say, 12 under par, ladies and gentlemen, that's called 12 under par, is better than if you are what? 12 over par. The winner of the tournament is going to be the person that has a score of 12 under par, not 12 over par. Okay. Yeah, golf is a sport where the more negative your score is, the better off you are. Right? That's a rare thing. Most sports are just the opposite. All right. We ready to move on?
Yeah.
Okay. Here we go. Let's go to our book and see if we can close out the rest of the time with some fun here. All right, we're going to dive into our textbook and see if we can do a couple of these problems involving the order of operations. So make sure you get something to write on, something to write with, and please do demonstrate your steps with these problems, as that keeps you out of trouble. By chipping away at these order of operation problems, you're going to have a good chance at them. If you try to do them all on one line or do them in your mind with your arms folded, it's not going to happen. There's going to be nothing but mistakes. Okay, so try to just have patience and write it out step by step by step on your paper. That'll keep you out of trouble here. What? We don't want that. Okay, here we go.
I got a quick question. Is any of this going to be classwork or is it just for our notes?
I do have Liz, I'm in a couple classworks I'd like you to try with the order of operations here. We got that, it's a 203 now. All right, just cut through the chase here and get to the order of operation problems, and here they are. Okay, I want everybody to do problem number 81. And we'll call this classwork, I don't know, what is it? Classwork 6 maybe? Okay,
Six.
go ahead, number 81. Ladies and gentlemen, just be careful with your signs, okay? Do number 81. Hopefully we can navigate through this problem correctly. Go ahead. Remember the order of operation. Oh, just for the record, between the -3 and the open bracket, ladies and gentlemen, what operators understood to be tucked inside there?
Multiplication.
Multiplication, understood. So it's -3 times the quantity inside brackets. There you go. All right, let's take a look at this here. I wrote the original problem down. Order of operations is going to have us inside the brackets first, correct? And inside the brackets, I see I have addition and I have subtraction. Order of operations say when I have operators on the same level of precedence, addition and subtraction, we default by working strictly from left to right. In which case I run into addition before I do the subtraction. So I'm going to add a positive 6 and a negative 10. A positive plus a negative, we take the difference and attach to what? Larger sign. And now I am still inside the brackets. I have to subtract. Subtracting a negative 2 is the same thing as adding a positive 2. Subtraction is the same thing as adding the opposite. A negative 4 plus a positive 2, we take the difference and attach the larger sign. Finally, we have to deal with multiplication. A negative times a negative is always a positive. Did anybody get positive 6 at the end of the day there?
No, I don't know.
Yes.
Yes.
Good, there's some signs. If you did not get the positive 6, first of all, are we showing our steps on our paper? Are we showing these steps here?
Yes.
That's how we stay out of trouble, okay? If you try to do this all at once, it's gonna get all tangled up. All right, nothing but mistakes. All right, now, another reason why we show our steps is because if we don't get the correct answer, we can go back and try to troubleshoot where the mistake occurred, okay? Just remember, when you go from one line to the next line in your paper, don't forget to bring things down we have not gotten to yet, including grouping symbols. Lose grouping symbols from one line to the next, you're going to lose your precedence, and the whole problem's going to come unglued, okay?
Is it a way you could have like practice problems with those as well?
Yeah. Oh, heck yeah.
Okay.
I can give you a whole bunch of extra practice here. All right.
Okay.
All
I have
right.
a question.
Go ahead.
Do we have to write the step out where you switch it from -4 minus -2 to
No,
negative?
no. Look, I don't mind if you leave out subtle steps, okay? I'm just concerned with if you try to do it all on one line, okay? Don't do that. That's going to be nothing but chaos.
Okay, yeah, I had,
Yeah, show the main steps. If you want to take some subtle shortcuts, no problem, okay?
okay, cool, thank you.
All right. Ready to move on to another one, ladies and gentlemen? Okay. Look, the key to this is going to be a lot of practice, and I can't emphasize it enough. Practice is the key to starting to assimilate all of this into our minds. It's only going to come through a lot of practice. All right, I want to back up here, and you can use a calculator to help you out with number 80, but I want you to do number 80 next. Just remember the order of operations, ladies and gentlemen. That's the key. Don't forget them and don't waver and deviate from them, and all shall be good. Try number 80. Still classwork number, what is it, 6 or 5 or whatever. It's part of your classwork, number 80. All right, I wrote the original problem out. Order of operations, say we do exponents first. So we need to square 14, which is to say 14 times 14, 196. We need to cube or raise 5 to the third power, which means 5 times 5 times 5, which is 125. We need to square or raise 8 to the second power, which means 8 times 8, which is 64. After exponents, then we see we have nothing but additions and subtractions. So we work strictly from left to right, in which case I have to subtract first in this case before I add. 196 subtract 125 is 71. Technically, that's the same thing as 196 plus a negative 125, 71. Now, 71 plus 64 gives me a positive 135. Anybody get that final answer there?
Yes.
Okay,
Yeah.
great. And, I don't mind if you type in the entire expression on your calculator and check your answer. Please do that, But by the same token, you want to still be able to just, first of all, do it manually first. Convince yourself you can lay the steps out and get the correct answer. And then maybe if you want to, try to, merge that with the calculator way of doing things, go ahead and do that. No problem. All right. All right. I got another one I want you to add to classwork. This may be the last one. Let's go on down. I want you to do 87. Number 87. The key is just remember the order of operations and chip away at this one step at a time, and all shall go great. Okay. Try number 87. There. All right, go ahead and work on that. All right, there it is, all laid out there, ladies and gentlemen. Wrote it down first. We're in the innermost nested set of grouping symbols, parentheses nested inside brackets, nested inside braces. We got to do 4 times 3 first, which is 12. Then I'm still inside the brackets, so I subtract. -10 subtract 12 is the same thing as -10 plus a -12. Notice I keep bringing everything down from the next line. You can't lose things from line to line to line. All right, because if you do, like if you go from the first line to the second line, you lose the braces or the brackets, you're going to lose your precedence and the whole problem will fall apart. All right, so we got it down to this. I'm still inside the brackets. A negative plus a negative is always a negative, and we add. Still inside the braces. We multiply. Positive times a negative is a negative. Now I have division versus subtraction. I need to divide before I subtract. -56 divided by a +8 is a -7. And -7 subtract a -66 is -7 plus a +66. And a negative plus a positive, we take the difference and we attach the larger sign. You got your answer. Did anybody get that? 59.
Yeah.
All right. You see, with patience and perseverance, ladies and gentlemen, showing your steps, you're not going to, you're going to meet with success more times than not. All right. So I know it seems a little laborious to write all these steps out, and there's a couple subtleties in here that you could probably omit and take some shortcuts on. But the bottom line is you got to show some steps. You can't just muscle this all out on one line there. That's just too much to do there. Okay. All right. Okay. So that is the classwork that I want you to turn in. Ladies and gentlemen, I'm gonna stay on camera here, and I'm gonna work one more out here. Okay, I will work it out. Okay, it's not classwork. All right, we're all done with the classwork today, but I'm gonna work one more out. If you want to stay or hang on to see that, you can do that, or if you got to go somewhere, by all means leave, and hopefully I'll see you in a couple of days. Okay, but I'm gonna do another problem here. The class, like I said, if you don't have time, you can run, but I just want to do this so that you can watch this later on the video. I'm going to do problem number 89. So I'm going to entertain problem number 89 here. I'm going to work that one out. And this will give you another, another one to look at and watch. And it can only add to your understanding of this use of order of operations here. So this will just be added on to the video, like I said. So if you have to go. You can watch the video later on. All right, here we go. I'm going to work this one out. Order of operations, say I go inside the braces, but nested deeper inside the braces is a set of brackets, but nested deeper inside the set of brackets is parentheses. I have to begin to write in here 8 minus 6. Notice I put an equal sign, and on the next line, I bring down everything that I have not gotten to. Failure to do this is going to lead to your problem becoming fragmented very quickly, and it's all going to fall apart. All right, 8 minus 6 is 2. Okay, that's the same thing as 8 plus a -6. 2. I'm going to drop the parentheses around the 2, no longer needed. Still got to bring the closed brace down, though. All right, I'm still inside the brackets. Order of operations, say I would deal with the exponent next. I got to do 9 squared, which is 9 times 9. That's 81. Next line of your paper, put an equal sign, bring everything down you haven't gotten to. All right, I'm going to replace 9 squared with 81 now. All right, order of operations, I'm still inside the brackets. I'm going to add all these numbers together. I'm going to take care of adding them all together. So 25 plus 81 is going to be 106 plus 2 is 108. I'm going to retain the brackets around the 108. You could drop them, but if you drop them, make sure you put multiplication between the 5 and the 108. Still inside the braces, I need to multiply next before I add. 5 times 108 is next. 5 times 108 is gonna net me 540, I believe. Still inside the braces, a negative plus a positive, I take the difference. And the difference between 540 and 16 is gonna be 524, and it will be a positive. I'm gonna drop the braces around the 524 now, no longer needed. Finally, 32 take away or minus 524 is the same thing as 32 plus a negative 524. Positive plus a negative, we take the difference and attach the larger sign. Negative 492 is your final tally on that problem, and we're done. Okay. All right. So I worked out several here. I will stay on the line if there's any other questions.